Hello everyone, let me walk you through the lab activity for this week. We're going to be studying pressure in a fluid. So what we're going to be doing here is we're going to try to determine the density of the fluid that's in this tub here. And we have this little pressure gauge which we can click and drag and kind of move around to measure the pressure at different depths. And I'll show you how to do that in the simulation here later. And so what we're going to do is for different depths, h, let's say 0.4 meters, 1.2 meters, and so on, we're going to record the pressure in the fluid at that point. Now here, h is the depth. So this is the distance below the surface of the water down to where we're interested in, not the distance from the bottom up, okay? So this is the distance here, so be careful. So we do that for a bunch of different depths h, and we record that pressure in this table here. Now, the goal is to get the pressure of this fluid, but how are we going to plot this in order to help us do that? Well, we're always going to start with a physics equation. In this case, our pressure in the fluid equation, P equals rho GH plus P0. So as a reminder, P, this is the pressure in the fluid. Rho, that's the density of the fluid. G is gravity, 9.8 at the surface of Earth. And H here again is the depth. And P0, this is the pressure at the surface. This is the air pressure right above the surface of the water. So in order to figure out how to plot this, we need to use our linearization equation, y equals mx plus b. Well, if we look here, these look in the very similar form, which is nice. So you see that the pressure that we measure is in the same position as the y-axis. So we're going to plot pressure on the y-axis. Our other data point is depth h. So you see that h is in the same position as our x-axis here. So let's plot on our x-axis, let's plot the depth h. And then we see that rho g is in the same position as our slope value m. And the air surface pressure is P0 is in the same position as our y-intercept value. So our experimental value for the density of the fluid times g, rho g, is the value that our slope will give us in our plot. And our experimental value for the surface air pressure, P0, is the same as our experimental value for the y-intercept from our plot. So here's that data that we took. And we're going to plug it into Desmos. So here, remember, on the x-axis, we're going to plot depth h. And on the y-axis, we're going to plot pressure p. So I took that data that we took from the simulation, we plugged it into our Desmos. And I know this is hard to see, so it's going to give us the slope value here, which is m is 9607. It's also going to give us the y-intercept value of 101,877. But what does these mean? How are we going to get the density of the fluid from these equations? So remember, with how we chose to plot this, that the value for our slope is going to be our experimental value for the density times g. So we know the slope is equal to the density of the fluid times g. Well, here we can just solve for the density of the fluid. That's our goal after all. So we just divide g to both sides. So solving for our density rho, we get rho is the slope divided by g, where our slope is 9607, g is 9.8. We can plug those in and we arrive at a density of 980 kilogram per meter cubed. Similarly, for the y-intercept, we know that the y-intercept is our experimental value for the surface air pressure. So our y-intercept is 101,877. Therefore, our experimental value for the surface air pressure is 101,877 pascals. This week's activity is going to involve 3 steps. The first one is going to involve acquiring data. The fluid that you're going to be looking at is different than the one that I just did. So you're going to drag this around and record the pressure at different depths. You're going to fill in a table. And then you're going to take that and plug it into Desmos and plot it. Remember, we're plotting pressure on the y-axis and depth on the x-axis. So therefore, our experimental value for rho g is our slope, and our experimental value for the surface air pressure, P0, is the y-intercept. From there, you're going to answer questions in the lab assignment in the module, but let me show you how to do the simulation first. So when you click on the link, this is what's going to take you here. So the first thing we're going to do is we're going to click in the bottom left here, this question mark 1. So now it changes the fluid to some unknown fluid of some unknown density. And we want to fill this all the way to the top to give us more fluid to do data experiments with. So I'm going to drag this into the right and fill this up all the way to the top. Then I'm going to grab a ruler, and we want to measure the depth. So that is the distance from the surface to where we're looking at. So we're going to take this ruler, I'm going to drag it so that the 0 mark is at the very surface of the water. And I'm going to click and drag my pressure meter, okay? And so the pressure meter is going to record the pressure at the very bottom tip of this triangle, okay? The first data point we want is at 0.4 meters. We got to look here carefully in this ruler. because there's only 5 tick marks between 0 and 1, which means that every one of these tick marks is 0.2 meters. So if our first point is at 0.4 meters, we have to go to the second tick mark. So it's 0.2 meters, 0.4 meters, 0.6 meters, 0.8 meters, and 1 meter. So let's go to the second tick mark. So we want to make sure the bottom of this triangle is parallel with the 0.4 meter tick mark here. So our first data point is 108.054 kilopascals. So we're going to take that and we're going to plug it into our Desmos plotter. Now, we want to plot it in pascals, not kilopascals. So this is 108,054 pascals. That's the number that we're going to put into Desmos. So here we go. Here's the Desmos. Here's the 0.4 meters that we're looking at. And so we're going to put in our 108,000 and was it 54? Yes, 54 pascals. So don't put 108.054. You put 108,054 in for our y value because we want our plot to be in pascals and not kilopascals. So then what you're going to do is you're going to click and drag this to the other different depths that you're going to do it at. You can also measure the surface air pressure is one of the questions, so be sure to do that. Once you fill this out, go ahead and go to the module, answer those questions, and let's get to it.